P block elements. See, already we were studied that is group 13. The P block elements contained in group 13, 14, 15, 16, 17 and 18 element. That is the group wise element. Already we were studied the group 13 and 14 in class 11. Now we are going to study the remaining 4, group 15, group 16, group 17 and the group 18 element. See, the group 18 element. What are the group 18 element that is called nitrogen family? So the group 15 elements called nitrogen family because the nitrogen is the first element of the group 15. See, here the nitrogen family carries what are that? That is nitrogen is the first element, then arsenic, antimony, bismuth and like this. So here phosphorus also. First we have to see nitrogen, phosphorus, arsenic, antimony and bismuth. So these are the group 15 element. Based on that atomic number 7, 15 for phosphorus and arsenic for 33, antimony for 51 and bismuth for 83. So here the first we will discuss the electronic configuration. This means the general electronic configuration. The electronic configuration of the that is the general. That is the general electronic configuration means they are end with that is the valence cell electronic configuration, or you can tell that valence cell electronic configuration. That is valence cell electronic. For example, with the valence cell electronic configuration, generally there is NS2 and the NP3. This is the valence and how it has come. That means, for example, nitrogen. Nitrogen, the atomic number is 7. So we can write 1s2, 2s2, 2p3. See, this is the valence cell. So we can write like this. Similarly, phosphorus. Phosphorus is you can write this neon 3s2, 3p3. You can write 1s2 instead of that helium. Helium instead of 1s2 also you can write. So this is the valence electron. So look, the number that is the group 2 here changes only 3, but s orbitals and p orbitals are same. That is why the ns2 np3. So this is the general electronic configuration. The similar way for arsenic, AR 3d10 4s2 4p3, SB 5s2 5p3, and with bismuth 6s2 6p3. That is the valence electron configuration. Then atomic and ionic radii. See the atomic and ionic radii. That ionic radii, covalent and ionic radii, that is increase in size down the group. Usually down the group, increase in size. See, this is the increase in covalent radius from nitrogen to phosphorus. The covalent radius are increases from nitrogen to phosphorus. However, from arsenic to bismuth, only a small increase covalent radius is observed. That is, see 70 for nitrogen, phosphorus 110, arsenic nitrogen is 70. This is the covalent radius. Phosphorus 110, arsenic 121, bismuth antimony 141 and bismuth 148. So this is the increasing order. here that increase the colon this means gradually that is increasing the nitrogen to bismuth increases because of this is the presence of the completely filled d orbitals like this, the completely filled. Here no d orbitals are involving, here the d orbitals also involving. So completely filled d orbital, or in the case of this case f orbital, because of the heavier member. Then the ionization enthalpy. Ionization enthalpy. So ionization enthalpy. Ionization enthalpy usually decrease down the group, the increasing of the atomic size. So because the extra stable of the half filled p orbital. Here the reason is half filled p orbital. So the ionization enthalpy of group 15 elements much greater than the group 15 element is much greater than group 14 element. This is the order of the successive ionization enthalpy that expected like this, that is the delta Hi, sorry, delta H I, the I indicates ionization enthalpy. 1 the ionization enthalpy, 2 the ionization enthalpy, 3 like this. So this is the ionization enthalpy term. Then electronegativity. Electronegativity values generally decreases down the group with increasing atomic size. However, the heavier elements, the difference is not much pronounced. For example, antimony and bismuth, that's same 1.9 and 1.9. This is for bismuth and this is for antimony. But in the case of electronegativity for nitrogen 3.0, phosphorus 2.1, and then arsenic 2.0 like this. So this is the order. So the last two is not difference much, it's same electronegativities are there. Then the physical properties of the group 15 element. So physical properties of group 15 element, they are the polyatomic, that is dinitrogen is a diatomic, while others are solid. Here the metallic character increases from down the group, that is for example nitrogen and phosphorus is a non-metallic nature, so the non-metal. And the arsenic and antimony metalloids. And the bismuth is a metal. So metallic characters are increases because due to the decrease in ionization enthalpy and increasing in the atomic size. So the boiling point increases from top to bottom. The melting point also increases up to arsenic, and then the decrease up to bismuth. That is except nitrogen. Because of that, except nitrogen, all elements shows allotropy. Then the chemical properties. Here the chemical properties, mainly the oxidation state. The oxidation state of the element, that is -3, +3 and the +5 is exhibited. That is the tendency to exhibit -3 oxidation state, that is decrease down the group due to increasing size and metallic character. So it shows like this. So in fact the last member of the group, that is bismuth, hardly forms any compounds in -3 oxidation state. So the stability of oxidation status, that is +5, that's mean decreases down the group. So The stability of the oxidation, for example, bismuth 5. So bismuth 5 compound forms, that is BiF5. The stability of plus 5 oxidation state decreases and the plus 3 status increases. So because of due to inert pair effect. So the nitrogen exhibit plus 1, plus 2, plus 4 oxidation also. Here, see that also when reacted with the oxygen, the phosphorus also shows plus 1, plus 4 also. It sums also acid. So in the case of the nitrogen in all oxidation state from plus 1 to plus 4 tend to disproportionate in acidic solution. That is, for example, nitrous acid HNO2. There's 3 moles of HNO2 to produce what? React with readily oxidize, it forms nitric acid, water and nitrogen monoxide. So in the case of the phosphorus, nearly all intermediate oxidation state that is disproportionate into the plus 5 and minus 3, both alkali and acid. However, the plus 3 oxidation state in the case of the arsenic and the antimony bismuth become increasingly stable with respect to disproportionation reaction. Then the anomalous properties of the nitrogen. What is the anomalous properties of nitrogen? Because here nitrogen is the most electronegative element in their group 15 element, that is the high electronegativity element. So and because of due to small size, so ionization enthalpy and the non-availability of the d orbital. So the nitrogen has a unique ability to form p-pi the multiple bond. p-pi multiple bond. So then other elements having like a small size and high electronegativity, for example carbon, oxygen. So that the heavier of elements of this group do not form p-pi bonds, and their atomic orbitals are so large and diffuse that they cannot have effective overlapping. But p-pi bonds with itself and other elements not possible. So here the large and diffuse, that is the nitrogen exists a diatomic molecule with a triple bond, because N2 exhibit what, that is N triple bond N, so that it having a triple bond atom. That is here that the consequently the bond enthalphy, like bond enthalphy is for 941.4 kilojoule per mole. The bond enthalphy is like this. So it's mean very high bond enthalpy. So on the contrary, the phosphorus, arsenic, antimony forms a single bond like a PP, AS, and SB bond, SB. So bismuth forms a metallic bond in a elemental state. So single NN bond is weaker than the single PP bond. Because the high interelectronic repulsions of the non-bonding electrons. So owing the small bond length. See, the catenation tendency is weaker in the nitrogen. Another factor of the which affect the chemistry of the nitrogen is the absence of the d orbitals in the valence shell. So the for nitrogen, that is cannot form d pi p pi. Nitrogen cannot form because they do not involve d orbital element. So example R3p phosphorus, like R3 P is equal to CH2. Here the R indicates alkyl group. So the phosphorus and arsenic can form d pi bond. So because of the transition metals, when their compounds like phosphorus with C2H5 thrice arsenic C6H5, C6H5 thrice. So act as a ligand. These are the act as a ligand. Then the reactivity towards the hydrogen. The reactivity towards hydrogen, reactivity towards oxygen, reactivity towards halogen, reactivity towards the metal. Here the first we will discuss the reactivity towards the hydrogen. Here all elements of that is group 15 element, the types there is elements you can write like this. They form like this, the H3, that is where E is the nitrogen. Here E indicates nitrogen, phosphorus, arsenic, antimony or bismuth. So here the some of the properties of these hydrates we can see that is in your table 7.2. Properties of hydrates are group 15 elements are given, that is ammonia 101.7, phosphine 141.9, arsenic hydride 151.9, so antimony hydride that is 170.7. So some properties are given, that is the stability of the hydrate decreases from ammonia, that is ammonia to bismuth hydride BiH3, so which can be observed from their bond dissociation enthalpy. Here the reducing character to hydrates increases. So ammonia is the only mild reducing agent. So mild reducing agent. So here that while BiH3, that is the strongest reducing agent, this is strongest reducing agent compared to other hydrates. So here that basically the decrease, that is the order of the hydrates like this. This is ammonia, NH3 is greater than PH3 is greater than ASH3 is greater than SBH3 greater than or equal to BiH3. So this is the increasing basic, that is the basicity. The basic character increases. Then the reactivity towards the halogen. The reactivity towards the halogen, it's the forms are two types, that is all element forms are two types, that is E2 oxide from the oxide, E2O3 and E2O5. That means E indicates nitrogen, phosphorus, any element. Here the oxides of higher oxidation state in the element is more acidic than that of the lower oxidation state. So acidic character decreases down the group. Acidic character decreases down the group. So oxides of the type like E2O3, the nitrogen and phosphorus are purely acidic, and arsenic and antimony amphoteric. Bismuth is a predominantly basic. So these are the characters of the reactivity towards the oxygen. Then reactivity towards the halogen. Element react to form, that is the two series of halides like EX3 and EX5, that is trihalides and pentahalides. So nitrogen does not form pentahalides due to the non-availability of the d orbital. So the pentahalides are more covalent than the trihalides. So all trihalides elements, they except those nitrogens are stable. In case of nitrogen, there is only NF3. NH3 known to be stable. That is trihalide except BiF3. BiF3 are predominantly covalent in nature. Why pentahalides are more covalent than trihalides mean there is the higher oxidation state or high polarizing power. So these are the reason. Then reactivity towards the metal. The reactivity towards the metal is react with metal for a binary compound. It is with -3 oxidation state. So such as calcium nitride, calcium nitride, calcium phosphide, sodium arsenide, zinc antimonide, and bismuth, magnesium bismuthide. So these are the reactivity towards the metal atom. Then next is the dinitrogen.